All right, so last one is talking about compound events. So previously you found probability of simple events, which means one singular event. But now we're talking about flipping a coin twice. Or what happens if we do this and then something else. Or this or that. Okay, so now we're talking about two or more events occurring at the same time. Okay, so that's what a compound event is. It's an event consisting of two or more simple events. When we do this, what's important to know is they're going to use words such as or for compound events. They're going to use the word this or that is happening. Okay, so let's do an example together. You roll a number cube. What is the probability of rolling an even number or a 3? So what we're going to do is find the probability of each event separately. So the first thing we're going to do is find the probability of rolling an even number. So on a standard number cube or a standard die, what's the probability of rolling an even number? Is 3 out of 6 or 1/2. What's the probability of rolling just a 3? Just a 3 is 1/6. Now, because it's or, these we add up the two probabilities. So because it's or, we add them up. We add 1/2 plus 1/6, which you could do in your calculator. Or you know that to add fractions, you need common denominators. So we're going to get this to 6 by multiplying by 3. Okay, so we're doing 3/6 plus 1/6, which is 4/6, which simplifies to 2/3. So now that's your probability, is 2/3. Okay. So if you see the word or, you add. If we see something like and then or and, you multiply. Okay, so I'm kind of getting ahead of myself. So now that we have compound events, there's two different types of compound events. And when I made this, they're kind of out of order. So there's, and I apologize, there's independent events. There's independent events, which we're going to talk about. But first, I want you to cross off the word overlapping. And I want you to write dependent. So dependent. Okay, so there's independent and dependent events. So there's independent and dependent events. Okay. Let's talk about dependent events first. So dependent events are events where the outcome of one event, so events where the outcome of one event directly affects the other event. Okay, so some big things here. Directly affects. So in a problem, if you're trying to figure out how would I know that it's a dependent event, if it says in the problem that it's not replaced. Okay, so you'd know if it says it's not replaced. So what this means is if we're taking out marbles from a bag and I want to find the probability that I get the red one and then a blue one, Okay, so I take the red one out, or I take one marble out, and I don't put that marble back in. That now changes the probability of what's in the bag still. Okay, so that's a dependent event. An independent event are events where the outcome of one event does not change the outcome of the other event. So it does not change the outcome of the other event. Okay, so, and what that'll look like, since it does not change, this one's going to have replacement. So it's saying we take the marble out of the bag and then we put it back in. Okay, so let's look at this example here in the middle to kind of freshen ourselves up with this. So I roll a number cube. What's the probability I roll a 2 and a 5? Okay, so because of the word "and" here, I know that it is going to be either a dependent or an independent. So does me rolling a 2 change anything with me rolling a 5? Hopefully you're thinking no, which means that it's independent. So it's an independent event. And why? Because the result of the first roll, does not change the second roll. Okay, so now that we know that it's independent, so that's always where we're going to start off with to define whether it's independent or dependent. Okay, so after we do that, then now we have to find the probability of each event separately. Okay, so the probability of rolling a 2 is 1/6. What's the probability of rolling a 5? 1/6. Okay, now we take these two probabilities, and again, because it says "and," now we multiply. Okay, because it says "and," now we multiply. So we do 1/6 times 1/6. And that's going to give me 1/36. So that's our probability. Okay, let's go to the back and do a couple of these examples together. So the first one says, I roll a number cube. What's the probability I roll a 3 or a 6? That word "or," this word "or," tells me that it's a regular compound event. So I should be adding. So I should be adding my fractions. So the first thing I want to do is find the probability that I'll roll a 3, and then the probability I'll roll a 6. So the probability I'll roll a 3 is 1 out of 6. The probability I'll roll a 6 is 1 out of 6. And because it's "or," I add them. So we should get 1, 2, 6, which simplifies to 1/3. Okay. Looking at number 2, I roll a number cube and flip a coin. What's the probability you get an even number and land on tails? Does me rolling a number cube affect how I'm going to flip the coin? Hopefully you're saying no. So that tells me that it's independent. And again, I know to choose that because of the word and here. So because of the word and, I have to choose between dependent and independent. And in this case, it's independent. Okay, so let's find our probability separate. And remember, this tells me to multiply. Okay, so probability I'll get an even number on a number cube is 1/2. An even number when I land on tails is 1/2. When I multiply those, I get 1/4. I'm going to do one more together with you, and then I'm going to let you go. All right, number 3. What is the probability that the first 3 cards drawn from a full deck of cards are kings? Okay, and it says they are not replaced. So they're not replaced. That tells me that this is dependent. And that tells me I'm multiplying. So first thing that if you don't know, there's 52 cards in a deck. So 52 cards in a deck. So, and there's 4 kings. So that means my probability of my first draw being a king is 4 out of 52. But now I'm taking that card that I drew out of the pile. So now how many cards should I have in the pile? If I've taken one away, I should only have 51. And we're assuming that the card I took away is a king. So how many kings should I have left? 3. Okay, so now I have 2 kings in my hand, in theory. So now I've taken 2 cards away from the original 52. So now for my third draw, I have 50 cards left. And out of those 50, if I have 2 kings in my hand, 2 of them should be kings. Okay, and then when we multiply fractions, we multiply straight across. So we do 4 times 3 times 2. Or if you want, I would probably just throw this whole thing into the calculator, which is honestly what I would do if I was you. But so when you do throw this in the calculator, your fraction should be 24 over 132,600. And I'm sure your calculator spit out a decimal. So the decimal should be 0.000181, I think. Let's see. 6200. And when you plug this in the calculator, you should get, if you round a little bit, 0.000181. Okay, so just be really careful there. Look at these first 3 examples when you're doing the next 3 for me. Okay, so pause the video. I want you to do the next 3 and check your work. And make sure you label whether it's independent or dependent. Okay, that's part of the process. So pause, check your work, and then go on to the homework. Okay, so for number 4, sorry, you should have gotten 24 out of 400, which simplifies down, or you can make it a decimal at 0.06. Okay, because they're independent, they both stay 20. Whereas number 5 is dependent, so our number decreases because we're not returning that sock back to the bag. Okay, and that answer is 0.084. Again, I'm rounding, okay? Last one is dependent, and again, this number goes down because it's not returned. And whereas we had 2 red marbles to start with, we probably, hopefully, have a red marble in our hand. So when we reach for another marble, hoping it to be red, there's only 1 red marble left in there out of the 5 marbles. Okay, and that's 1/15th, or that is 1/15th is about 0.067. Okay. So now I want you to try number 7. That's your homework. Where it says P in parentheses, that's just the probability of black and yellow. But one thing here that I want to tell you, that this should say blue. Okay, it should be blue marbles. So there's 9 blue marbles. Okay, just so you know. So there should be 9 blue here. Okay, hopefully that's helpful. There's your homework.